Hi, everybody. I'm a career low talker, so if you can't hear me in the back, just like point to the ceiling or something, and I'll try to speak up. Um, so I wanted to talk about electric vehicle supply equipment, location suitability. We're not really breaking any ground. It's a pretty standard suitability analysis, but we know there's a lot of funding that's going to be available for this. So I felt like it would be helpful to share some of the criteria that we put into our suitability analysis. Um, and so it was all done with the ArcGIS Pro Suitability Modeler. If you're not familiar, it is on the analysis toolbar in ArcGIS Pro, and it'll run you through all the steps you need for your suitability model. This particular project was a partnership with the town of Chapel Hill, town of Harborough, Hillsborough, Orange County, and the University of North Carolina. And so that was our interagency stakeholder group. Um, so for some of the background, like I said, these agencies have all kind of, there's no formal agreement in place, but we want to coordinate on climate action initiatives, just so we can kind of have that fill in the gaps. We don't want to be duplicative. We want to have good coverage for our jurisdictions. Um, and so this project is really kind of preparation as a group, as a collaboration for some of the state and federal funding that will be available. And like I said, we really just want to be efficient with that. And we want to show the grant, people reviewing the grant that we're making that attempt to maximize those resources if they were awarded to us. And I think one of the biggest things here was we wanted to not only develop that common planning tool for each of the jurisdictions, but we also wanted to have a tool that the public could use, because we're oftentimes, as municipalities, will engage those developers and say, hey, yes, you can build here. We need to put infrastructure in for EVSE. Where can we do that? So that's something that developers could look at beforehand, before they're having that conversation, and kind of instill that into their concept design. And for our stakeholder group, it was primarily the sustainability coordinator or analyst for each of these organizations. I was the GIS analyst, and everyone else was the sustainability folks. So you can see, hopefully pretty well, these are our suitability criteria all laid out in the graph. They're shown here in order of weights, so highest to lowest weights. One of the biggest things for us was making sure that there was a significant equity component to this analysis. So you can see out of the 100%, we have 65% of the standard criterion for that location suitability. And then we added equity criterion that were 35%. And they're listed here. I can kind of scroll through slowly so you can see them. But I'll go through these one at a time and just kind of let you know how we treated them. Again, we're not really breaking new ground with the way we analyze or process the data, but I think it's just the combination of criterion that really define the analysis. So first and foremost is points of interest. So points of interest are actually 3 separate layers. So POI 1, 2, and 3. They're all weighted differently, but together they get 30% of the entire analysis, because points of interest, that's where people are going. That's where we want to encourage everyone to install EVSE within a reasonable distance of these locations. And so to get these, we extracted these commercial and civic kind of address points from Orange County address data, and we used the land-based classification system codes to extract those appropriate uses. So there was no residential in the point of interest. This is all commercial and essentially destination type locations. And so with the points of interest, like I said, we have multiple jurisdictions. Because the weight's so high, we wanted to make sure that the jurisdictions could review their point of interest and use their own local knowledge to, yay or nay, and then also rank these in terms of the point of interest 1, 2, or 3. And so we did that using a web app, which was the easiest way for me, especially because I could farm the workout to everybody else. I didn't have to do it myself, I always like to do that if I can, because then you also help people, become power users of GIS products. But we configure the web app so they could use that knowledge. And basically, it just lets them edit, select a point from their jurisdiction. Those points are pretty small. But you could select a point and rank it, change the name, delete it, whatever you need to do. So it was pretty intuitive for them, so they could get the work done without having to get into a real desktop type environment. And like I said, because points of interest were so important, I really wanted that interactive validation, because they're such a high weight. And so I just wanted everyone to kind of have ownership of, so yes, these are valid. This is what we're basing this on. So the points of interest were classified 1, 2, or 3. And essentially the classifications were done based on the use pattern for that particular use. So we're looking at traffic, traffic volume. Is it a bank? People coming and going? Is it a gym where you might have a little longer dwell time? So those dwell times and that foot traffic is how we're kind of distinguishing those 1, 2, or 3 classes. And we use the maximum walking distance of a quarter mile. Our Chapel Hill Suitability Analyst indicated that is pretty much the maximum preferred walking distance from park to destination for most consumers, patrons, heavy in that range. But that's kind of how we modeled that parking to destination behavior. We put those points into the network analyst solver and let it rip. And you can see it generated, hard to see again, but it did generate a ton of polygons there for us. And so what we did is where the polygons overlapped, we summed the count of POIs for each of those polygons. So if we have 10 polygons, we take that number and we just summed it up. So you get a sense of where you have coincident overlaps for those services. Right? It does inflate your point of interest count, but really that wasn't so important as the relativity. This place is giving you more coverage relative to this place. Because we could always go back, we need to understand exactly how many points of interest we're serving. So then, they're converted to raster, reclassified and transformed in the suitability modeler. For this one, we use the MS large continuous function. If you're not familiar with suitability modeler, it gives you several different functions or ways to classify your data. Some of them are functions, like looking for large, midpoint, small values, etc. You can also classify them into distinct classes if you need to. And obviously, we preferred service area locations at a higher aggregated point of interest. That's what we're looking for. So that was a big part of the point of interest because, like I said, it really, that's where people are going. That's where we want to encourage the installation of ESVE, which is electric vehicle supply equipment. I don't know if I said that. But anyway. Next one is future development, right? So it's got a 14% weight, and essentially all the stakeholders took their future land use plans or their policy planning documents, and they classified them within our 1 to 10 suitability scale based on their own the knowledge of their intent of their organization within their jurisdiction. And then together, once they had done that, they had to come together and really try to reconcile those weights based on, how does my future land use class compare to a similar future land use class in a different jurisdiction. So I wasn't as much part of that discussion. You can see there's a lot of them up there, a lot of uses. But that was a good exercise for them to really kind of, I don't want to say synergize because I don't like that word, but they kind of brought it all together, for the future land use bit. And so again, we just transformed that. It was highly weighted because, like I said, these are areas that are knowingly targeted for future development. So that's the future land use map there. So next was daily vehicle miles traveled, right? So we wanted to understand what are our high volume routes through town. And so that started with the AADT data. We got a 10% total weight. Because again, we wanted to focus on points of interest, but you also want to focus on those high traffic corridors. So we started with AADT data, the average annual daily traffic from NCDOT. And you got to snap those to the routes because they almost never match your jurisdictional route that we maintain. So we snap those, um, and they're not all surveyed every year. So we had to use the most recent value from the last 5 years. You can see it's got pretty good distribution there in Orange County. So those are all the stations. And so what we did is we took those AADT route points, joined them to the corresponding route features, and if there were multiple AAD points on a route, we averaged them. It was questionable in terms of, a lot of times you might be reducing the volume if you're averaging, increasing the volume. But the group felt like it was maybe the easiest way based on the amount of time it had to do this. And so you can see with routes, so now we've ascribed those AADT values to the routes. I'm just going to say traffic data instead of AADT, it's easier. So we ascribe the traffic data to the routes, so we can symbolize there, as you can see. And so then we calculated the daily vehicle miles traveled, that DVT value. You can see the formula there. It's pretty simple. And again, that was from our sustainability analyst. They recommended the DVT. And it's shown here as orders of magnitude. There's the key, just up to the maximum. And if you're not familiar with this area, this is Orange County, North Carolina. That yellow line is 40 and 85 until the red splits off, so that's I-40. So that's kind of how you get your bearings there. Chapel Hill's down the southeast corner. And so to take those linear features and convert them to aerial features, we tessellated the study area into these 1 square kilometer hexagon bins, and we sum the route values, right? So anything that intersects within a bin, those values are set. And again, that's to kind of get away from the actual value. But for this, you're really looking at the relativity of those values. So that was what we were trying to preserve. If I had a mulligan, if I had to do it over again, I'd probably tessellate it using the triangular tessellation because they give you a more linear and symmetric corridor around your route features as opposed to the hexagons, which you'll see later really kind of have a legacy in the final surface. So we classified those into the suitability classes by looking at natural breaks in the data. And that was a process. I started with distribution charts. Sometimes that's too much for the sustainability folks. And so it's kind of a good idea to sort of rein in the parameters that you're using and just give them these simple decision points. And this is one of those instances where I kind of had to back off and just give them that simple decision point. But so the primary highway corridors in our area, like I said, 40 and 85, they're already accounted for in the federal DC fast charging highway corridor plans. So the areas around, right in the middle of that 40-85 corridor, we did not weight those corridors. There was some discussion, should we use them in the model, should we not use them in the model? We decided to use them as reference layers later on because essentially, if it's already planned for, then in our model, it would have to kind of have a negative weight. And we wanted to try to avoid negative weights, essentially. So next, with affordable housing, this is one of our major equity criteria. It's actually broken up into 2 layers, the total 17%, but it was 8 and 9%. So affordable housing data was essentially intended as a proxy for low to moderate income populations. So we're actually using these as a population segment rather than necessarily housing locations. And we're lucky, Orange County Affordable Housing Coalition did provide us with the subscription-based CoStar data. So that was super helpful. And that's just premium real estate data if you're not familiar with CoStar. But you can see, like I said, 9%, 8% respectively. And it's really centered in the municipalities. There's not so much around the county. And that was just a simple point density tool, right? So we had unit counts for any multifamily subsidized housing or NOAA. we use the point density to create these surfaces. And again, in this large function, so it's automatically looking for those larger values where you have more units. And like I said, we did separate these as distinct criterion. I presented them together, but they were separate layers because for subsidized housing in town, it's typically serving a lower income population. So that less than 30 to 60% area median income. And a lot of naturally occurring units in Orange County, this may not be hold true for everybody, but typically that NOAA serves at 60 to 80% unit. So it's kind of, by incorporating subsidized in the naturally occurring, it felt like we were capturing the less affluent population in that way. Another equity criteria was historically underutilized businesses, because it's a mouthful. And so this is also two data sets. This is historically underutilized businesses and Black-owned businesses. So it's 5% and 3% total weight, respectively. And we got this from the NC Department of Administration Office of Historically Underutilized Businesses. And essentially, we wanted to make sure that the model is highly valued to try to, I guess, recompense for the underutilization of these businesses and put in that equity piece. This data set could definitely be improved. The consensus with our stakeholder group was that there were a lot of businesses that were not in the data set, and it's probably just incomplete reporting or maybe latency in reporting. But it could definitely be improved by kind of doing sort of a local review, local validation of some of these points. And that was pretty similar. It was a network analysis. So we did a half-mile pedestrian network service area analysis. And again, once we had those, we put those into the count overlapping features tool so we could quantify how many service area polygons are overlapping and generate our weights from there. The weights here is a 1 to 10 scale, but all of these are classified between 5 and 10. Again, to put our finger on the scale, encourage utilization of these businesses through the installation of infrastructure. Next criteria is multifamily units. So it says, unlike the residents of single-family units, which town of Chapel Hill is like 88% residential, mostly single-family. But typically, multifamily residents don't have access, or don't have the option to install EVSE in their residence. It's a multifamily unit, and so they don't necessarily have access to that overnight charging. So we felt like that needed to be addressed. So what we did is we summarized all the residential address points from the Orange County addresses within building footprints, and then any building that was greater than 3, so anything bigger than a triplex, quadplex, we say that, then that was counted as a multifamily unit. And so from buildings, we converted to points, and then with the points, we actually, if there was clusters on the same street segment, we aggregated those. Just to kind of pare down the data, there is a facilities limit in the solver, so that bit, the aggregation bit for the address points is necessary to fit everything into the solver without trying to do multiple passes and then kind of mush it all together. So from the aggregated points, we chose a 5-minute drive time. And by we, I mean the stakeholders. I just asked them what the number is, and then I plug it in. They chose a 5-minute drive time as the reasonable maximum tolerance for someone going to an off-site EVSE for target, near home, essentially. So again, we put those into the network analysis solver. You can see generated 426 multifamily drive time service area polygons, which isn't really workable. So the next step, similar, put that back in the count overlapping features tool. And you can see, you start to see where they really overlap and kind of coming in on that network where you're generating the highest access for multifamily buildings. that was, instead it generated thousands of polygons, it generated 95,000 polygons. So it's a big data set. But it does lend itself to raster conversion in the small area, high volume numbers. And so then we again converted a raster, threw it in the suitability modeler again, and that's large. Like I said, we're not breaking ground necessarily. It's just these criteria that we put a lot of thought into how we're going to blend these, how we're going to blend them. So next was air quality. It was a little bit of a challenge with air quality. It is another equity criteria for us, but it was conceptualized as a function of the daily vehicle miles traveled values that we had, and it had to be more complex than that, right? Because otherwise we're just double counting the daily vehicle miles traveled. So that was kind of fun for me. I sort of got to dive in and figure out the best way to get that done, and I figured it was I may be saying this wrong, the empirical Bayesian Kriging tool, we'll say EDK, because that really supports that interactive exploration of how these values change as the distance from our routes change. So that was pretty fun for me. And we're estimating that PM 2.5 pollutant concentration. That's one of the smallest, if you're not familiar, that's one of the smaller particle sizes for anything. EDK does require point features as input. So what we did is we generated these points that represent our air quality network using the Create Spatially Balanced Sample Network tool, which I didn't know about until I was trying to figure out how to do this. And it was like a gold mine. I was like, hey, they got a tool for that, you know? So Create Spatially Balanced Sample Network. And then what we did is we just joined those to those daily vehicle miles traveled routes. So we could have that deviancy value for each of the points. And so once we had those values, we could estimate the PM2 pollutant. I used this reference here, the effects of urban form on ambient air pollution and public health risk. Not only was it a local study, it was hosted by the National Institute of Health, so I felt pretty good about the validity and the process. But that was our formula. That's in vehicle kilometers traveled, so we had to convert that to miles. We did consider some other concentration factors for pollutants, like the intersections where you have standing, engine revving, startup, and then higher slopes where you have to rev the engine to go up a little more. So that would increase the air pollution a little bit. It was a little too complex for this. The stakeholder group felt like we didn't necessarily need that level of complexity. So to get away from just double counting the DVNT, we incorporated the pollution reducing effects of tree canopy. So I just used the MLCD canopy layer, and then I assigned it a 0.8 value. So then when I multiply it with this one using times, I get that 20% reduction for the canopy area. I wanted to use LiDAR because I like LiDAR processing. We didn't have the countywide LiDAR. So that's the final air surface model, air quality surface model. This was a little more processing intensive than a lot of others, and it may just be because I was sort of nerded out on it. But the final surface, you can see it's really, again, it's more, like some of the other stuff, it's more relativistic, right? So it shows you where you might have higher values versus lower values. I wouldn't go use this to say, this is the actual value for the air quality pollution. So we're really relying on the relative estimates here. Here we have good old population density, definitely important. We gave it 5% because we kind of already covering that with some of the addressed units that we looked at. We estimated the residential level. Essentially, we just took address points, joined it to the census block group, and then we assigned the average household size value from the census block group to each address, which is handy if you ever need to do population estimates outside of those census block group shapes. We use whatever shape we need. So that's how we got the kind of that population layer. again, just a point density tool to create the population density surface. And then we classified 1 to 10. Again, in this large, like I said, it's not very complicated on the processing side. Parks, you might think of parks as a point of interest. They are, but after a lot of discussion, the group decided that since most parks were kind of under the jurisdiction of the stakeholders and the use patterns are consistent with EV charging times, they wanted to break parks out as its own layer. So we broke it out, gave it a 6%. Any large park, greenways, you know, anything that has a large area, we kind of took that area out, added only those areas that are accessible by vehicle or appropriate for EVSE. So no gravel lots, no road shoulders by the Duke Forest or whatever. And so here's the final result. You can see the legacy of the hexagons. It's pretty obvious. But in the end, we felt like it definitely incorporated the values that we put into it, the values that were brought by each of the stakeholders. And so I provided them with a drafted map, which wasn't as useful. It's more of an overview. But we really gave them the data product as a web application. You can see it's kind of weighted heavily towards those urban centers, but all of the suitability areas outside of those in the county area are still visible. So if you needed to, you could always resymbolize based on the relative range for those county maximum score was 8.3. So it's kind of important to think about frame the discussion within the actual fact. There's no such thing as it's and so I just zoomed in a little, kind of same thing. We felt like the resolution is a lot finer. It's a larger scale than most of the existing planning resources, so you can do a lot more kind of precise planning. And for this analysis, I felt like the regional scale represents the unified resource to support applications, joint planning initiatives, et cetera. We did give a simple map viewer. This is available online for the public. They didn't like the red-green, the stakeholders, they wanted different colors. So that's why we went to different. But this allows them to go in, see the suitability surface, but they can also toggle all the criteria layers to understand how those criterion layers are affecting the final suitability score. And they've already used this actually to apply for funding for the Charging and Fueling Infrastructure Grant Program, Triangle Clean Cities was the lead applicant. And this is for funding for public charging stations throughout Orange and Durham County. I don't know if anyone from Durham's in here. Anecdotally, I've heard they're going to try to recreate the analysis, which is great because I live in Durham, and that would be cool for me to see that used. Last one, analyst notes, definitely create submodels to do this. I did this first one in one large model, and as you add criteria, the processing time it's just exorbitant or maddening depending on your personality. And then definitely balance the deference to the stakeholders' desire and to participate with what the decisions I'm presenting, right? I needed to give them those simple decision points. Don't say, hey, here's the tool parameters. How should I fill this out? Right? I try to give them those simple points.
Thanks, Dave. Yeah. We might have time for one question or two if anybody has one. Okay.
Hi, Caitlin Meyer with GeoDecisions. I'm just curious what your timeline was. Like, how long did your coordination efforts run? And
yeah, so I want to say from the time the group started to the delivery for the final surface, maybe a month and a half. It wasn't that long for me. It wasn't that long. Yeah, yeah, they did a good job coordinating themselves,
And just Dave.
David Key, ESVE. Just a quick question on the points of interest. Was there any consideration on the points of interest based on any idea of dwell time at these POIs versus like a quick hit at a gas station versus a library?
Yeah, yeah, that was one of the, we looked at the idea of volume, pedestrian or patron volume, and then the dwell time that they would be in. So, you know, uh, savings and loan type banks where you go, you meet somebody, it's a higher point of interest, like an ATM or something like that. So yeah, that was definitely probably the primary consideration is, are you getting high volume traffic? Are people staying long enough where they would be able to sufficiently charge the fee?
All right, I think go ahead and wrap up here. So thanks again.